Welcome to the Deep Dive. We're here to cut through the complexity and give you that essential understanding fast.
That's the goal.
Today, we are taking a deep dive into DX NetOps.
Think of it like the central nervous system for your whole digital setup.
Yeah, it monitors everything, diagnoses problems, makes sure your network, your apps, everything is running smoothly.
Right. But instead of digging through piles of documentation, we're doing something a bit different. We're pulling practical insights straight from, well, practice questions.
Specifically from the DX NetOps 250-585 exam prep materials, questions and their explanations.
Exactly. So consider this your shortcut to really getting how this powerful system works in practice. Our mission, extract the core knowledge from these scenarios. So to give you a roadmap, the exam in our discussion really revolves around 9 core areas. These are kind of the building blocks for managing a network effectively. First, there's the basic setup, DX NetOps architecture and deployment. Then how it tracks performance management or PM.
What it does when things break, that's fault and event management, often involving Spectrum. Then there's the software-defined side, virtual network assurance, VNA.
Right, dealing with virtual networks.
Understanding the traffic itself, flow analysis, using things like NetFlow and SFlow, how it connects to other tools, integration and data sharing.
Integrations are key these days.
Keeping it all secure, obviously, security and certificate management, getting back up after problems, backup and restore operations.
You always need a plan B.
And finally, figuring out what went wrong, troubleshooting and diagnostics.
And if we step back for a second, looking at these categories together, it really shows how a modern, comprehensive network solution needs to weave all these different threads together.
Yeah, it's not just one thing.
Exactly. It's not just about seeing what's happening. You need to understand the architecture, the performance, how it fails, how it recovers, how it stays secure. Grasping how these areas connect, that's fundamental to seeing the whole picture of network operations.
That's a really good point. It's about seeing these ideas in action.
Right.
Right? Not just as a list.
Precisely.
And that's why we're using these practice questions. They give us concrete situations. So let's learn by dissecting these scenarios, digging out the practical knowledge hidden inside. Okay, scenario 1. Let's unpack this. You're planning a DX NetOps deployment across multiple physical sites. You have your central system, but what component is absolutely essential out at each remote location, to handle local polling and aggregate data efficiently?
Right. The component you absolutely need at each remote site is the data collector.
Data collector.
Yeah. Think of it this way. Installing a data collector locally means it talks directly to the devices at that site. It does the polling there.
So it keeps the traffic local initially.
Exactly. This massively reduces the amount of raw data flying across your wide area network back to the central system. It prevents the main server from getting overwhelmed.
Makes sense.
It's all about efficiency and scalability, especially when you've got lots of sites. It's basically pushing the collection and some initial processing closer to the source devices.
That makes perfect sense for efficiency, having that localized hub. But what happens if one of those data collectors fails, at a remote site? How does DX NetOps handle that to avoid blind spots?
That's a really important question. You're right. You don't want a single point of failure. So typically, deployments are designed with redundancy.
Okay.
You might deploy, say, 2 data collectors at a site, or have failover configurations set up. If one collector goes down, another one can take over its workload.
So the monitoring continues.
Exactly. It ensures that data keeps flowing and you don't lose visibility into that remote location just because one component failed.
Okay, moving from collecting data to securing access to the data, our next scenario focuses on authentication. Which component acts as the main broker for a single sign-on SSO into the DX NetOps portal, the portal being the main web interface, right?
That role belongs to the SSO gateway.
SSO gateway.
Yes. Its whole job is to handle that single sign-on process. It essentially acts as a middleman.
How so?
Well, it brokers the user's credentials between whatever external identity system you're using, maybe LDAP, Active Directory, something like that, and the DX NetOps portal itself.
Wow.
So you log in once through your company's standard login, and the SSO gateway handles authenticating you to the portal without needing a separate password. Seamless and secure access.
So the SSO gateway definitely simplifies things for users. Log in once, access everything. But thinking about security, does having one central point like that, the gateway, introduce any unique risks we should think about, even with SSO.
That's a smart point. Centralization always means that central point becomes more critical, potentially a bigger target.
Right.
So the key is really locking down the SSO gateway itself. Strong access controls, keeping it patched, configuring it very carefully to prevent any weaknesses. And of course, the security of your main identity provider, like Active Directory, is still absolutely critical. The gateway relies on that being secure too.
Makes sense. Okay, let's shift to being prepared for trouble. Specifically, thinking about performance management backups. If you need to restore a full configuration backup, what kind of file are you typically looking for? What's the extension?
For a full PM config backup, you'd expect to find a file ending in .tar.gz.
.tar.gz.
Okay, yeah, that's a standard format. It's basically a compressed archive, like a zip file, but using tar and gzip. It bundles up all the necessary configuration files and data points needed to restore the entire performance management setup.
So it's a complete package ready to go.
Exactly. Makes transfer and restoration much more straightforward. You grab that one file and you should have everything you need for that snapshot in time.
Got it. Backups are for recovery, peace of mind. But what about managing the network proactively? Understanding faults and events as they happen? That brings us to Spectrum, the fault management side. What's the main idea behind using a global collection in Spectrum?
Okay, global collections in Spectrum. Their main purpose is to organize your network models for alarm correlation and reporting.
Organize models.
Yeah.
You mean like grouping devices?
Precisely. You logically group your network devices, routers, switches, servers, whatever models you have in Spectrum. In a large environment, this is essential just to keep things manageable.
Right.
But the real power comes from how this grouping helps with alarm correlation. Spectrum can use these collections to understand relationships between events on different devices within the group.
So it can connect the dots if multiple things go wrong.
Exactly. It might see related alerts and consolidate them into one primary actionable alarm, which cuts down on all the noise you might otherwise get. Plus, it makes reporting across specific segments of your network much easier.
That grouping definitely sounds useful for clarity. But networks change, right? New devices get added, old ones removed. Are these global collections static? Do you have to manually update them all the time?
Good question. No, they don't have to be static. That's the beauty of it. You can define global collections using dynamic criteria. Instead of just listing devices, you can set rules, like include all devices with an IP address in this range, or all Cisco routers in this building, or even base it on custom attributes you've set.
So they update automatically.
Correct. When a new device comes online and matches the criteria, it automatically gets added to the collection. If a device changes or is removed and no longer matches, it drops out. This keeps your groupings, and therefore your alarm correlation and reports, accurate without needing constant manual tweaking.
Nice. Okay, let's switch over to traffic analysis. You need a quick view of the top talkers on your network who are using the most bandwidth over the last, say, 24 hours. Which dashboard widget in the NetOps portal is designed for that?
For that specific task, your best bet is the Flow Summary widget.
Flow Summary.
Yep. It's built exactly for that, giving you a quick visual summary of the top consumers of bandwidth. It'll show you the top IP addresses, maybe interfaces or applications, depending on how it's configured, over the time period you select, like the last 24 hours. It's the go-to for spotting bandwidth hogs quickly.
Perfect for a quick check.
Yeah.
Now let's talk integration again. Suppose you want performance metrics, data from performance management, to show up directly within one click, which is Spectrum's main console. What two things must be set up for that to work?
Right. Integrating PM data into one click. Two critical pieces need configuration. First, the performance management data source.
Okay, the data source.
This basically tells Spectrum where to find the performance management database and how to connect to it to pull those metrics. Second, you need IP domain mapping.
IP domain mapping, what does that do?
It's essential for context. Spectrum organizes things by IP domains or landscapes. Performance management might just have raw IPs. IP domain mapping links the IP addresses from PM data to the correct network domain within Spectrum.
So one click knows which device and which part of the network the metric belongs to.
Exactly. Without that mapping, the metrics might come in, but one click wouldn't know where to display them correctly in its topology views. So data source to get the data, IP domain mapping to place it correctly.
Got it. Sticking with integration, but this time with a third-party tool. Let's say you're integrating DX NetOps with AppNeta. What two specific authentication objects are needed to set that up?
Okay, AppNeta integration. For authentication, you typically need two key things. an Appnita API access token,
Right, for the API.
and an SSH public key.
SSH key. Okay, why both?
Well, the API access token is used to authenticate the programmatic calls between DX NetOps and Appnita's API. It's like a password for the software to talk to each other securely.
Makes sense. And the SSH key.
The SSH public key is often used to establish secure shell sessions. This might be needed for DX NetOps to securely collect certain data from Appnita monitoring points or potentially push configuration changes related to the integration. It provides a secure, encrypted channel for those kinds of interactions.
Okay, secure API calls and secure shell sessions. Makes sense. Now, let's talk about proactive alerting. You want to set up alerts based on thresholds like if interface traffic goes too high, what configurations are absolutely mandatory to make that happen?
Threshold alerts on interface traffic, yes. Two things are essential here. First, you need a metric filter for AFFOUT octets.
A metric filter, so you're telling it what to watch.
Precisely. If effectets and if octets represent the bytes coming in and going out of an interface. The filter tells the system, I specifically care about these metrics for my threshold. Second, you need a device collection.
Ah, the collections again. So you tell it where to watch.
Exactly. The device collection specifies which group of devices or even specific interfaces on those devices this threshold rule should apply to. You define what metric to watch and which device interfaces to watch it on. Without both, the system doesn't know what to monitor or where.
That makes sense. You need the what and the where. Okay, now, for something that sounds tricky, troubleshooting potential database issues. This one gets interesting. What kind of problems, what inconsistencies might you see if you restore the main Spectre server database, but you don't restore the related DDMDB, the device data manager database?
Oh, this is a critical one. It really underscores how vital database synchronization is, especially in complex systems with interdependent data stores.
Right.
If the Spectre server database, which holds the core network topology, models, and relationships, gets restored from a backup, but the DDMDB, which holds more dynamic, detailed device data like current configurations and operational state, doesn't get restored from the same point in time.
Right.
You're asking for trouble.
What kind of trouble?
You'll likely run into mismatched alarm history and incorrect model linkages.
Okay, explain those. Mismatched alarms.
Yeah. The Spectre server DB might know about historical alarms related to models that, according to the unrestored DDMDB, have different configurations or maybe don't even exist in the same state anymore. So your alarm history becomes unreliable, maybe even nonsensical.
And incorrect model linkages.
The Spectre server DB defines how devices are connected, the topology. The DDMDB has granular details about those devices. If they're out of sync, the links or relationships shown in Spectrum might not reflect the actual device states recorded in the DDMDB.
So the network map is wrong, essentially.
In a way, yes, or at least inconsistent with the detailed device data. It leads to inaccurate monitoring, potentially missed problems, or false alarms. You're operating with conflicting information, which can be worse than having no information at all.
Wow, that analogy about having two different maps of the same city really drives it home. One shows the roads, the other the building details, but they're from different dates. You can see how that would cause chaos.
Absolutely. Database consistency is paramount.
Okay, one final scenario. Let's dip our toes into the world of Kubernetes. Increasingly relevant. If you need to check the environment variables being used by the flow collector pods running in Kubernetes, which specific Kubernetes objects would you look at?
Right, Kubernetes. For checking environment variables, specifically for pods like the flow collectors, which are often run as containerized applications managed by Kubernetes, you'd typically inspect either the deployment or the daemon set object that manages those pods.
Deployment or daemon set? Why those?
Because deployments and daemon sets are Kubernetes resources used to define how applications, packaged as pods, should be run and maintained. The configuration for the pods, including the environment variables they need to start up and operate correctly, is defined within the specification of the deployment or daemon thread.
So you look at the management object to see the pod settings.
Exactly. By examining the YAML or JSON definition of the relevant deployment or daemon set, you can verify exactly which environment variables are being passed into the flow collector pods when they're created. It's crucial for troubleshooting if a pod isn't behaving as expected. For anyone managing any complex system, really, how often do we truly understand the interdependencies between all the components before something breaks and forces us to learn?
That's a really good question. Probably not often enough.
Right. Every single configuration choice we make, every integration point we set up, it creates ripples. It has downstream effects. So the thought I'd leave folks with is, what unseen connections, what hidden dependencies are waiting in your systems for a deep dive? Maybe in places you think you already know inside and out.
A very compelling thought to end on.
Mhm.
Food for thought indeed. Thank you for joining us on this deep dive.
My pleasure.
And thanks to you for listening. Until next time.